Okay, so if we're comparing natural ecosystems to farms, here's an interesting question. How can you have pest problems in nature, right? Like if you have a diverse ecosystem like a forest or a grassland or your backyard or whatever, you don't see a single species completely erasing another one very often, right? Like they have predators and they have competitors and there's other limits, right? If you have a whole bunch of rabbits all of a sudden, well, you're going to get a whole bunch of hawks pretty quick. And I'm sure that the rabbits will run out of population potential because they don't have enough places to hide or enough water or something. So it's actually pretty rare that in nature, one species will just blow up all of a sudden and start to eat up others. That doesn't really happen very much because, they're complex ecosystems. One goes up, one goes down, another competitor comes in, so on. But in farms, pests can be a really big problem. And in many ways, we've brought this problem on ourselves. I need to tell you a story, which is also a big vocabulary term and an important part of this class that didn't get a study goal, but it kind of should have. In the 50s and 60s, there was this guy named Norman Borlaug, and that's a name you've probably never heard, but I really think you should have. This guy had what is maybe the most important idea ever. That's a bold claim, but hear me out. He saw that human population was forecasted to grow very quickly, and he looked around and said, well, we don't have enough food. People are starving already. And with bonkers population growth, we're going to need more food somehow. So this dude was just a nerd. He worked at a university and he's like, let's make more food. And it worked. It really worked. In like a 20-year period when human population doubled across the globe, this guy coordinated an effort and shared research across the planet to triple the global food supply. In the time it took human population to double, he spread information to make food systems 3 times more productive. In other words, this guy saved more lives in advance than anyone else ever has, ever. I really honestly think that this idea, because he gets so much credit by himself and he saw it coming and he avoided the problem, I think this is the most life-saving idea ever. And he's dead. And when he died, NPR did like a 3-minute story on him, and he just disappeared out of the history books, and nobody knows this guy's name. He knowingly, on purpose, not to get rich, led a global effort that allowed 2 to 3 billion humans to have enough food. That's some props right there. And this thing that he did, it was called the Green Revolution. And when we say Green Revolution, everybody thinks like Priuses and Patagonia jackets and like steel water bottles, but that's not the Green Revolution. The green revolution that's happening now might be the green marketing revolution, or you could say it's the environmental awakening or whatever. But the term green revolution was taken. There's a very specific reason why I originally called my program the Green Academy. Kind of throwing back to this food meaning of green. The Green Revolution was a period of time in the 1950s and 60s when 3 major concepts revolutionized food production. Number 1, super crops. Number 2, industrialization. And number 3, chemicals. You're going to have to know this. Now, super crops were selectively bred. That doesn't mean genetic modified, okay? Genetic modified crops is modern, like the year 2000 or so. But this was 1950s or 60s. We didn't really do DNA stuff back then. Selective breeding is like you take two short dogs and you get a Chihuahua, right? Selective breeding. So, you take a really sweet tomato and you breed it with a really sweet tomato to get a crop of really sweet tomatoes. Selective breeding. But in the Green Revolution, we wanted specifically not sweeter, not tastier, not better for sauce, not smaller seeds or whatever. We didn't even care about eating quality. We wanted higher yield, like grasses that instead of growing for 6 months will grow for like 2 months and then make their seeds, dwarf grasses. Or like high yield tomatoes that make twice as many fruit. They taste like crap, but they make a lot. Or whatever, stuff that grows very quickly, stuff that has larger grain tassels, whatever. Super crops. Number two, we started to think big. Instead of like mom and pop growing stuff in the back of the old family farm, no way. We started to go big time, like build a dam, dig a canal, bring 1 billion gallons of water so we could ignore the weather, bring in tractors, big machinery, lay down huge fences, airplanes to deliver fertilizers. Farming went from acres to miles. It became an industrial endeavor. Assembly line ideas, efficiencies of scale. 50s and 60s, right? It kind of makes sense after World War II. And number three, we figured out the chemicals. There's a dirty, dirty story here. Those Nazi doctors were really good at chemistry, and American chemists sort of fought with them. And after World War II, why waste all of that scientific experience? And we basically hired chemists from all over the world to come to the one country whose economy was still growing after World War II. Keep in mind, all the other countries lost. They either got bombed or they lost the war. Meanwhile, United States, we won. So we come home and we're like, we'll make the cars. Sorry, Germany. And we're like, we'll grow the food. Sorry, Europe. And then we're like, we got all the money, right? So let's fire up the factories. And we went big on chemicals. We got into the synthetic fertilizer thing. People started to spray stuff on their clothing so the water wouldn't soak in anymore. We started making like plastic into clothing and polyester and whatnot. And we just figured out how to make plants grow bigger and better, like the steroid revolution. Before we had any idea about consequences, we just went for it. And it worked. Globally, we were able to increase yield and then double the yield and then eventually triple the yield over a period of about 20 years. That's unheard of. There's never been an organized global effort to do anything that fast. I can't believe we don't talk more about the Green Revolution, but B, even though it worked at feeding more people, there were some really interesting unintended consequences. Let's get back to the pests. Imagine, like you've probably heard before, that when you're selective breeding for one trait, you're gonna give up another. Like if you're gonna just sample in the human population the 1,000 most beautiful people, you didn't necessarily pick the healthiest or the smartest or the best voices. You just picked the most beautiful. So you're going to sacrifice some other variables if you keep choosing beauty. And if you want to make a dog with a pug face, Maybe it can't breathe, but whatever, you can get that face. And in the terms of plants, we got higher yield, but we gave up hardiness. You know, like those dudes that do all the crazy steroids and they lift a whole bunch of weights, but then they break an ankle when they roll off the curb. Kind of the same idea. We made plants that grew really, really fast to give us a whole lot of food, but they were delicate. They couldn't fight off bugs. They have thin skin. They have small leaves that are easy to eat. We gave up pest resistance. Plus, we started growing in a new way. Instead of a little family farm that grows a little bit of this and a little bit of that, we started to grow just one thing. We went from polyculture, grow a bunch of different stuff, to monoculture, grow one thing. Imagine if you're a broccoli bug and you fall out of the mouth of a bird and you land in the middle of a broccoli field that goes 4 miles that way and 2 miles that way, and as far as the eye can see, all the way to the mountains in the other two directions, right? At the high school, if I get broccoli bugs, they'll eat a few broccolis and then they're like, well, I guess we're out of here. But imagine if a broccoli bug falls in Broccoliville, California, all they see is broccoli. So their populations just grow and grow and grow and grow and grow, and there's still more broccoli. So we had plants that were weaker in volumes that gave pests a huge advantage, right? Nothing else around, just broccoli or whatever. So we would kill the bugs, and tomorrow, like, the couple of survivors have had 10 billion babies and they're back. This is called pest resurgence, right? When you use pesticide and the bugs come back, and we would spray and we would spray and we would spray, and tomorrow they'd be back, and then we'd spray, and then tomorrow they'd be back. And you have to do something to end up in the same place, like being on a treadmill where you take a bunch of steps but you're not going anywhere. This is called the pesticide treadmill. We were getting to the point where, like, you would just spray pesticide like 1, 2, 3 times a day, every day, no matter what. And these pesticides are expensive, and they have unintended consequences, like your neighbors get sick and your farm workers die. And so part of the Green Revolution was we had to figure out how to make really burly pesticides. When food production went industrial, pesticides had to go up to 11. How can you protect 100 square miles of feeble plants that are growing on steroids? You got to bring in the next generation of pesticides. So let's talk about the history of pesticides. For thousands of years, pesticides were just toxic elements. Like, you didn't use a lot because you wouldn't want to eat that stuff. The very first pesticides were just plain poison. I'm not kidding, like copper and like sulfates and arsenic, like cyanide. Cyanide was a pesticide. You would just find stuff that kills you and then just dust it on the plants until it kills the bugs, and then hopefully you'd wash it off before someone ate it. Inorganic pesticides, because they're just a toxic element. And this was like the Roman period, and like a bunch of famous Romans, it turns out, died of pesticide poisoning and stuff. And later on, farmers started to develop what were called botanicals, things that are derived from plants. Like, oh, the bugs aren't eating that one, let's grind it up and spray it on the corn. And that worked for a while. Garlic oil, nicotine, coincidentally, a bunch of drugs are just pesticide made by a plant to keep the bugs from eating the plant. And then some human figures out like, oh, if you cook it and then you grind it up and then you steam it and then you evaporate and then you do the thing and then you chop it up, you can snort it. So coincidentally, the botanicals includes a whole bunch of things that we know as drugs now, because we saw that they were chemically active in life, and somebody's like, maybe if I just try a little bit. But during the Green Revolution, keep in mind the chemical industry was going gangbusters. We came up with like next level pesticides. These were called POPs. Now, it's probably important to say that we came up with better pesticides that happened to be persistent organic pollutants. I'll clarify. Persistent organic pollutant means a chemical that never breaks down, persistent, right? So it's a synthetic chemical. Humans build this chemical, and it's persistent. You got to define this, so make sure it's somewhere in your notes. I made myself notes on the screen to define. Persistent is something which is never going to break down. It's long lasting. Once you build this chemical, it doesn't change. Right? Like you can do chemistry at home and then those chemicals will like degrade somehow, but not these. They are very, very stable. And they're organic, which means they're stuck to carbon. And that's important. Get ready your definition, because things which are stuck to carbon look useful to most consumers. Right? Because carbon compounds have carbon bonds, and the natural ones are like sugar and fat, like those are important for your diet. So all life likes carbon. So what if we make a molecule with carbon so that it'll be absorbed into life? That's really stable, so it'll keep doing what we want it to forever, and then we just attach something toxic so we can make a chemical that's long lasting, that gets into life and will kill stuff. That's a nice pesticide, right? You spray it on the field and it'll be there until the bugs absorb it. And when the bugs show up, they go, meh, and it gets into the body of the bug, and the bug doesn't know any better, and now it's got pesticides inside of it, and eventually the bug dies of poison. These, look at my notes, persistent organic pollutants are absorbed into pests and kill them quickly, and the definition you need is long-lasting, carbon-based, and toxic persistent organic pollutants. Now, we've made other chemicals that have these properties for other reasons. That's what I was telling you. Pesticides are persistent organic pollutants, but we make other stuff like fire suppressants. Like you spray this stuff on the cushions in the couch so you won't die when you fall asleep smoking a cigarette. It's a thing, I'm serious. And we spray this stuff on the couch to keep it from catching on fire. It happens to be toxic if you eat the couch. Nobody eats couches. But it's carbon-based and it's long-lasting. So there are POPs which aren't pesticide. Write that down. There are POPs which aren't pesticide. But during the Green Revolution, we made pesticide POPs. FYI, in the hippie world, we sometimes call these forever chemicals. They're a chemical that we build, and once we build it, will last on Earth forever because it's persistent. Now, imagine how nice it would be if you can like spray something onto the outside of a human. And if any bug lands on that human and licks salt off the human because the human is sweating, that stuff will get into the bug and the bug will fall over and die. You know, like mosquito repellent. Imagine if you were wearing mosquito poison. Mosquito lands on you and it dies. Back in the day, we did this. There would be a truck that drove by in the morning, like an ice cream truck ringing a bell, you know, ding, 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 ding. And all the kids would come out. and they would stand in the street and they would get sprayed with DDT. Not kidding. And then the kids would play all day and the bugs wouldn't bother them. There was like free community pesticide sprays to keep bugs off people because we thought that would help control. I mean, it probably did help control the spread of diseases. And we made a whole bunch of pesticides that were extremely deadly. And they worked. They killed the pests. Hooray for us, we win. But as it happens, all of those are still knocking around on the planet somewhere. I just found out a place where my dad likes to go fishing doesn't, you can't eat some fish because there's high levels of DDT because there was a factory that dumped trash in that part of the ocean. So there's like a section of Southern California where you can eat like sand bass and croaker because of the DDT in that part of the world. That's like 50-year-old chemicals, but they're still in the food web and they still work their way into life, and life doesn't know better. Life is stupid. Life's like, I don't know, carbon. So we made a generation of pesticides that are forever toxic. And it turns out that's a bad idea because the water keeps moving around the planet. So we all suffer the consequences of these pesticides. Nowadays, we've got modern pesticides. And today, pesticides are a little bit more friendly. Generally speaking, pesticides kill all the bugs in the farm, but they don't survive very long outside the farm. Modern pesticides are super targeted, like they just work on beetles of a certain age or whatever. And they're also self-destructing. Like when sunlight hits modern pesticide, those chemicals will fall apart. Or when you get them wet, like it rains, the water will break the pesticide. That's called photodissociation or hydrodissociation. When sunlight breaks the bonds or when water breaks the bonds. Now modern pesticides hopefully can avoid the ecological problems. But there was like this period from like 60s, 70s when we had these like super pesticides, and that stuff is all out there. It's in you, it's in me, it's in our diet, it's in the ocean, it's in our food, it's in the bald eagles on Santa Cruz Island. Kind of gnarly, that special moment. They were this category of pesticides that never goes away. It was a really good idea until we realized it was a bad idea. That's it for number 11. Later on, we'll talk about other ways to manage pests, but that's probably not today.